Nearly 100 years ago, the great RMS Titanic came to rest at the bottom of the North Atlantic. More than 1,500 men, women, and children were killed when the ship went down. To this day, much of her destruction remains mysterious. But there are clues hidden in the cold and dark. Her torn and twisted wreckage still has a story to tell. Now, for the first time, a full-scale forensic investigation will tackle the case. An arsenal of high-tech hardware will perform a deep-sea examination. Pieces of Titanic will be dissected and analyzed. New techniques will reveal aspects of the tragedy never before witnessed or understood. Battling hurricane winds and hostile seas, investigators will work to unravel secrets nearly a century old. Titanic's true and dramatic story may finally be told, as scientists uncover answers from the abyss. Some 300 miles off the coast of North America, in the dark waters of the Atlantic Ocean, a group of ships has come together at the Titanic site. Experts from the United States, Great Britain, Canada, and France have convened with one goal. Their mission? To conduct the first full-scale scientific investigation of the Titanic disaster.
If there's any opportunity to try out this innovative technology during the first leg.
We don't really know at this moment the attitude of the ship when it hit the bottom.
Surprisingly, the destruction of Titanic is still mired in myth and controversy. But this unparalleled team of investigators hopes to set the record straight.
Now what we're seeing, this is the questionable area right here.
Immediately following the Titanic disaster, the world struggled for answers. Soon, a popular story emerged that seemed to explain everything. Titanic struck a mountainous iceberg. She sustained an enormous gash and sank in one piece, killing more than 1,500 people. For nearly 100 years, this was the accepted account of what happened that tragic night. When Titanic's wreckage was discovered in 1985, the world was shocked to learn there was more to the story. The great ship was actually torn in two huge pieces. Her bow and stern separated by nearly half a mile. To this day, we still don't know how the ship broke and scattered across the sea floor. This group hopes to change all that.
There's a tremendous amount left to be learned about the Titanic. Bringing these minds together, we should be able to come up with a pretty good answer to what happened, why it happened, and in what sequence it happened.
To reconstruct the disaster, the team at sea will work with investigators on land.
At the rear end of the bow.
Together, they will focus on Titanic's wreckage,
In the main wreckage field next
a forensic approach likened to studying a corpse in a murder mystery.
to give everybody a feel for it. The word forensic immediately conjures up images of pathology labs and someone poring over cadavers. And to a certain extent, we're doing that.
Huge difference.
What we are doing is looking for signals and signs and often very small pieces of information to build the bigger picture.
From its position.
Four major events surrounding the destruction of Titanic are still shrouded in uncertainty. What is the true extent of the iceberg damage? Scientists now suspect it's a series of small slits, not a 300-foot gash. But can they prove it? They also know that Titanic broke into pieces the night of the disaster. But how did this actually happen? And why? One of the biggest mysteries is what occurred when the ship left the surface. How did the bow survive the 2.5-mile descent relatively unscathed? And what happened to the stern to utterly destroy this part of the ship?
Ship's heading is 150. All right, Kurt, 100 up. 100 up, I got 100 up. One in.
To answer these questions, the investigators divide the wreck site into two fields of operation. The crew aboard Ocean Voyager will concentrate on Titanic's bow, which lies more than 12,000 feet below. To reach their target, they'll deploy the Magellan 725. Magellan is a remotely operated vehicle, or ROV. For this mission, Magellan is equipped with state-of-the-art underwater cameras.
Kirk, if you can stand in front of the camera, I can get a flesh tone off you. Set this up. That's good.
Once Magellan reaches the Titanic site, its powerful lenses will become an investigative research tool.
Magellan will be able to get a very close-up look at the whole structure, at various pieces of debris down there, and be able to pick up what we hope are a lot of visual clues. We'll get detail like nobody has seen before.
To launch Magellan to Titanic requires a 15-ton crane and an 8-man crew. The robot is attached to the ship by a cable thousands of feet long. Magellan will receive instructions and transmit live images through this umbilical cord.
Troy, you got me all fouled up. I'm all stopped. Let me know when you're close. We're close. Bring your head 90 right, 100 full up. Getting wet, Kurt. Okay, let me know when you want hydraulics. Hydraulics up. Hydraulics are on. Pull that tether a little bit. Troy, start working on the depressor. Yeah, get that sling out.
As Magellan now fights the current on its 3-hour trip to the site, a half-mile away, the crew aboard Nadir prepares its mission to the exploded stern. Little is known about this part of the wreck. The manned submersible, Nautil, is being turned into an advanced photographic platform. Heading up the effort is oceanographer Paul Mathias. He outfits Nautil with high-resolution cameras and powerful deep-sea lights. Pictures of the stern wreckage will be fed into this tiny sphere and stored on computers designed for the mission.
We are about to try something that's never been tried before. Very exciting.
Nautil now begins her long trip to Titanic. A voyage that will take her crew to one of the most inhospitable environments on Earth. Temperatures are freezing. The water pressure is bone-crushing. All that will protect her crew is a 4-inch thick titanium shell. Nautil and Magellan are now underway on an historic mission. It's hoped their photographic reconnaissance will add a new chapter to understanding the Titanic disaster.
In the past, ships have vanished, and it was walk away and leave it because there was nothing could be done. Now we have the technology to visit these wrecks, look at them in detail, and to understand why they failed and why they were lost.
We're going to presume that you'll be coming in on the bow, on the starboard side.
Aboard Ocean Voyager, scientists meet with the Magellan team to plan their search for the actual iceberg damage. Bill Garsky is a naval architect and a leader in the field of marine forensics. David Livingstone works for Harland & Wolff, the shipbuilding firm that constructed Titanic.
There is a potential entry into the hull.
These men want to find and photograph a section of the damage that doomed the ship.
It is a rather jagged hold. There is some obstructions.
When Titanic's bow struck the ocean floor, it plowed up sediment, concealing the deadly iceberg damage under a mound of mud. In 1996, scientists used sonar to peer through the silt. Their data suggest that the iceberg caused a series of thin slits that flooded and sank Titanic. Today, investigators wonder if part of the fatal damage might not be buried in the mud.
Made some calculations, or there was something that...
In fact, it might be visible to the naked eye.
I think if we can find some exposed surface of the ship that was not in contact with the sediment, perhaps, and I say that perhaps, we may find the iceberg damage that the ship sustained.
Before they can begin looking, the pilots must fly Magellan to Titanic's bow. A risky endeavor.
Roger that, heading down.
As the ROV approaches the bottom, it pauses to check its tethering system for tangles.
It's settling out. Things are getting safer. Another 20 meters, 090, Bruce.
More than 2 miles of cable floats freely through the deep sea. This is more than enough to get snared on any wreckage at the site.
Moved 50 meters, 280, roger. Stand by, Bruce.
We are a tethered vehicle. We go all the way from the surface to the vehicle on the bottom. Obviously, we do not want to get that tether fouled. And the Titanic is a major fouling obstacle.
After several hours, Magellan reaches the sea floor.
You're looking at bottom right there.
The landscape is desolate, barren. Somewhere in the darkness lies a colossal structure, once 4 city blocks long and more than 100 feet high.
12 foot, dead ahead. Something's real close. There's the wreck. All right, 6 feet off, come on up. It's pretty close, don't get closer. Watch your verticals.
Titanic's bow is a haunting sight. Surprisingly elegant, despite its destruction.
Troy, nice job aiming those lights.
Roger that.
The Magellan team runs the cameras through a series of system checks before they begin searching for the iceberg damage.
Hey, Emil, how we doing? You're all right down there? Or no?
Yeah, we're cool.
Okay, so
Livingstone and Garsky test the skills of the Magellan pilots. In order to find what they're looking for, they fly dangerously close to the wreck.
doesn't actually look like this.
They head to a spot where one survivor claimed he saw damage nearly a century ago.
What we believe is some damage with the ship either.
On the night of the disaster, deep below the luxurious accommodations, survivor Frederick Barrett is working in Titanic's boiler rooms. Barrett helps stoke the boilers, which supply steam power to the engines. After Titanic hits the iceberg, chaos erupts in the boiler rooms. Barrett is among those who struggle to save the ship. Barrett sees water jetting in 2 feet above the floor grate in Boiler Room 6. An hour later, he's forced to abandon an adjacent boiler room.
A large volume of water came through. All at once, I saw a wave of foam come tearing through between the boilers, and I jumped for the escape ladder. Leading fireman, Frederick Barrett.
Patiently, the team slowly combs the outside of the wreck, looking for the damage Barrett saw from inside. To pinpoint Barrett's location, the team drops down the starboard side of the ship, counting hull plates and portholes as they descend.
I'm still trying to go down. Am I clear on the left?
This is the only way to find the exact area described by Barrett.
See how that thing goes in and out?
Yeah.
With every second, Magellan gets closer to the target destination. If they can find the damage, it will be the cornerstone of their investigation. After hours of searching, Bill Garsky spots something in the encrusted wreckage. It's 4 o'clock in the morning.
Okay, is this the opening you're talking about?
Yeah, almost right on the mud line. There's something that looks like an open seam.
Hidden near the mud is a tiny opening in Titanic's side.
Yeah.
Yep. Yeah, that's an open seam.
You're kidding. It is?
See the room? Sure is.
And it's right where Frederick Barrett said it would be. It's a section of the actual iceberg damage.
Okay, let's get in there real tight and frame it up.
An elated team savors the discovery.
You can hang there, zoom in. Yeah, there you go.
I want to give credit to Stoker Barrett because he said he saw the seams open 2 feet above the foreplate, and that's where we are.
Okay, Ron, request is that you get the ROV as close as you can to that opening.
Upon closer inspection, the damage is telling. As suspected, it's not a puncture or a gash, but rather something more simple. A separation of steel plates. The plates should be held together by rivets, but rivets are missing. Some scientists have long suspected that rivets may have failed upon impact with the iceberg.
When the iceberg came and actually hit the ship, at the seams, the rivets could be failing. And by failing, we essentially feel that what would have been happening is the heads of the rivets would have been popping off. Okay. Once they pop off, the seams can open, you can have water coming in. Okay. The question is, why would those rivets fail?
Start right at this depth. Yeah.
Before Magellan is called back to the surface, it scours the ocean floor, looking for loose rivets.
Yeah, I couldn't get more than about 20 or 30 degrees.
Using the ROV's robotic arms, the pilots collect a steel sample with rivets still intact.
See if I can hold still and let it clear up a little bit. Maybe get it under and just hold it up.
The sample is carefully placed in a retrieval basket for the long journey back to Ocean Voyager.
7's on the cage, bending it. Backing up.
Tight.
Okay, you ready to pick them up?
Yeah. All right, secure lights and hydraulics. Okay, lights, hydraulics down. Got enough boom.
The following day, Weiss begins his work by thoroughly photographing the specimen. Next, he carefully removes the rivets. He'd like to know why they might have failed. At the time of Titanic, ships were held together by rivets, not welds like they are today. It's estimated that more than 3 million rivets were used to construct Titanic. Each beam, each piece of hull plate was attached to the ship by rivets. Titanic's rivets were made of wrought iron, which is essentially a mixture of iron and a substance called slag. At the time, it was difficult to monitor the mixture of slag and iron. And if too much slag was added to the mix, it could actually weaken the rivets. Investigators would like to know if this is what happened in Titanic's case. In a temporary lab aboard Ocean Voyager, Tim Weiss continues the search for answers. First, he cuts a cross-section to look inside. Weiss collaborates with materials scientist Tim Fakey, who's testing more rivets at the National Institute of Standards and Technology in Maryland. It was Fakey's past work that prompted further study of the rivets.
We sectioned 2 failed rivets that were recovered in '96, and looking at them metallographically under the microscope, you could see that the rivets had too much slag. So what we wanted to do in 1998 was to get more rivets from different places on the ship.
Working together, Fakey and Weiss examined rivets of all sizes, rivets used in different applications. They're measuring the quantity of slag, which is seen under the microscope as dark streaks. Some rivets have the optimum amount of slag, and the substance appears as little round particles. This sample, on the other hand, has too much slag, which will weaken the rivet. In their work, Fakey and Weiss continue to see variation in Titanic's rivets.
We've looked at rivets that are from various locations on the ship. Overall, 5 to 10% may be having a problem on the ship. We've looked at 30 out of 3 million rivets. So we're never going to be able to say definitely, but the trend seems to be there. The more rivets we look at, it doesn't go away.
Fakey's work raises provocative questions. Were small, flawed iron rivets Titanic's Achilles' heel? Or was the impact forceful enough to compromise even the strongest of rivets? We may never know for sure. In any case, we now know the damage that sank Titanic was quite small.
I think psychologically it was just unbelievable that something so small could have caused a loss. It had to be seen as catastrophic, and that was the perception of the day. Now, with hindsight and looking at the evidence, it's entirely possible for ships to be lost with quite small holes that can't be controlled.
For Bill Garsky and David Livingstone, the investigation is off to a successful start. But the work for these 2 men is far from over. The weather for the expedition so far has been very cooperative. Gentle swells make daily commutes a pleasure. These motorized boats, called Zodiacs, are a critical link between ships at sea. Today, expedition leader George Tulloch heads to Ocean Voyager to discuss the weather that lies ahead. Conditions can change very quickly here. Hurricane season has officially begun, and the Titanic site lies well within a known hurricane zone. The team is keeping its eye on Hurricane Bonnie, which has the potential to hit the site with devastating force.
See, this has shifted. Before it was coming.
Bonnie will have to be watched closely.
Has it going much further north?
Deep below the surface, the conditions here are still ideal. For the past several days, Paul Mathias and the crew of Nautil have been capturing the most detailed photographic record yet of Titanic's stern.
I'm going to sharpen up the exposure. I'm going to open the shutter. Nautil has the ability to move very, very precisely over the seabed, And while we're moving back, Nautil has the ability to move very, very precisely over the seabed. And while we're moving back and forth, we will be firing the cameras at the bottom.
Each of the images that Matthias captures is like a piece in a jigsaw puzzle. As the pictures are assembled, scientists build a unique view of the entire wreck. This process is called photomosaicing.
The pictures are there to tell a story. What the mosaicing does and what the individual videos do is to reveal a story within this wreckage. And each piece has its own little story to tell.
Scientists can now clearly see some historic and dramatic locations. On the stern, the third-class stairwell comes into sharper focus. The night of the disaster, this was a place of confusion and panic as passengers tried to escape the ship. Titanic's furthest aft deck also becomes more visible. Near these decks, many received last rites from Father Thomas Biles, while others took their chance by jumping into the icy waters.
Neither shall there be sorrow or dying.
On the ship's bow section, the davits used to lower lifeboats can be seen with striking clarity. Officer Charles Lightoller worked here for a brief period, evacuating Titanic. The mosaic also reveals the grand staircase. Today, it's a ghostly remnant of what it once was. With painful reminders of its past elegance. This skylight looks into Titanic's wireless room. A piece of the radio still hangs precariously from the ceiling. The night of the disaster, Harold Bride and Jack Phillips frantically sent out calls for help from this room until the water poured in. For the next several days, Matthias and the crew of Nautil photographed the wreck piece by piece. It will take thousands of images to complete this historic mosaic of Titanic. Late at night, Magellan heads back to Titanic.
Yeah, wait till we get around here and get the taglines on.
Investigators now turn their attention to one of the most astonishing events of the Titanic disaster.
Keep that loop outboard, because it's going to go up top.
The moment the great ship breaks into pieces.
Can I bring up hydraulics? Just tilt that pan and tilt down.
Bueno.
Let me know when I'm in the water.
You're in the water.
Okay, bring your head 90 right. 90 right. Okay, coming right.
To this day, much of the Titanic's breakup is shrouded in mystery. For passengers and crew, this was a time of utter horror. For those who witnessed the breakup and lived to talk about it, it was a terrifying spectacle.
You could see her propellers and everything. Her rudder was clear out of the water. And then her lights went out. Able seaman, John Bewley.
We pulled from the Titanic for a distance of a city block when Titanic began to shake to pieces. First-class passenger Lucille Carter.
While laying on a bundle of chairs, I could see the ship split in two. There was a rain of wreckage, and a big piece of timber fell on me, striking my vest. August Weichmann.
Today, investigators will comb the wreckage, looking for clues that might help to explain Titanic's violent destruction. Magellan approaches an area near the stern, known as the debris field. As it reaches the sea floor, Magellan sends power to its lights.
All right, looking 240, 600 feet out. Heading is 215.
Yes, we are in the south of the debris field, south of the stern. I don't know exactly at which distance, but probably 200, 300 meters or something like that.
Dead ahead, 60 feet. We're coming in stuff.
The wreckage in this area is staggering.
I got a nice big target at 270.
Massive sections of the ship stand like giant monoliths.
I'm gonna get right up above these things and look down in. Okay, it's gonna take me a little while to get over there.
Each piece has a story to tell.
Just snapping another 35. You want to get lower now? Yeah, turn right.
But deciphering what the wreckage means is incredibly complicated.
There's so much stuff around here. It's really difficult to figure out where it came from.
The process of interpreting the wreckage to reconstruct the disaster is called reverse engineering.
Looks like something that's definitely got ripped. Any ideas what that was?
It's the same approach investigators use to understand modern disasters, like airplane crashes.
Okay, I'm just gonna pan it to the right real slow.
Among the scattered remnants, the team locates a series of boilers. Each more than 20 feet tall.
This is pretty tall here. Roger.
These boilers may yield significant clues.
Yeah, because there is here one furnace, maybe there's one here. Yes.
Some survivors believe Titanic's boilers exploded, contributing to the breakup of the ship.
Fireboxes.
Investigators want to know precisely what happened on that terrifying night. During the tragedy, as Titanic is being evacuated, some survivors say they hear the massive boilers exploding, breaking free and tumbling from the ship.
While I was helping with the boats, there came explosions below deck, and the ship took a rushing in of the icy waters on the boilers. August Whiteman.
I heard 4 distinct explosions, which we supposed were boilers. First class passenger, Mrs. Stewart White.
As the investigators inspect the stern boilers, they can find no evidence of explosion.
The boilers from number 1 boiler room. It's a single-sided boiler. It seems in perfect condition. Therefore, it didn't explode or implode.
To be sure, Titanic's other boilers didn't explode. Investigators have to account for the ship's remaining units. Their search takes them to the bow section, where many of the boilers were housed. The decks here have collapsed, concealing a view inside the ship. But to the team's surprise, some wreckage has slipped away. For the first time, investigators can clearly see into one of the boiler rooms.
And what we found was all 5 boilers in place with no explosion damage. It gives us an indication that probably all 24 boilers that were in operation didn't explode and didn't leave their foundations.
If the boilers didn't blow Titanic apart, what could have caused it to break into pieces? Investigators now turn their attention to the steel itself. Could it have been flawed, contributing to the breakup? It's a highly contested theory. To settle the debate, the team needs physical evidence. An actual section of steel that broke free from Titanic. Investigators would like to cut a sample from a 20-ton section of hull dubbed the Big Piece. The piece is being raised as an historic artifact. But to the crash investigators, it's important for other reasons. The artifact came from the starboard side of Titanic, encompassing 2 upper decks of the break region. If it is weak, it could mean much of the steel here was also brittle. For retrieval, the artifact is connected to giant lift bags, which carry it 2.5 miles to the surface. Here, salvage teams work quickly to connect the piece to the recovery ship, a bay supporter. Suspended underwater, a piece of Titanic once again is touched by sunlight. As the crew works, they're careful not to cause any damage to this historic artifact.
Come on up. Bring it over to the side. Turn it around. Okay.
Despite their best efforts, it's difficult to control the massive weight in high winds.
This rope tight now, okay.
After several tense hours, a section of Titanic's hull is safely secured. David Livingstone and Bill Garsky now have a tangible link to Titanic's rupture.
Hey, look at this, right here.
We hope to learn much more about how the Titanic broke up.
There's been a lot of
and perhaps make a better explanation why the vessel is in the state she's in today. The gravity beating those days, I don't think it was. Yeah. Evac. Probably lead.
As the big piece makes its way to Boston for analysis, the expedition team monitors Hurricane Bonnie, which has stalled near the Atlantic seaboard. The hurricane is pushing bad weather their way. Nervousness underlies the proverbial calm before the storm. Many of the crew take advantage of the sunshine. It's hoped that rain and rough seas are all that hit the site, and that the hurricane never gets any closer. For now, it's a tense waiting game. The big piece arrives in Boston after a 4-day journey. In the harbor, materials scientist Tim Fakey meets with Titanic conservator Stefan Pennick.
On that side, you see a very flat edge over here, this region when we disassemble it. The big piece came from very close to the region in the stern where the big break occurred, where the ship broke up. So if we have a piece of the hull from right next to the breakup, it is entirely likely that that has steel that's very similar to the steel that was actually involved in the break.
This part? Can you put that on the light? The steel looks perfect.
Back in his lab, Fakey prepares a sample cross-section of the steel. Using what's called a fracture toughness test, he will measure its strength. This machine will subject the steel to forces in excess of 2,500 pounds. It's a slow bending process, similar to what Titanic went through the night of the disaster.
When the stern of the Titanic came clear of the water, the upper surface of the ship was loaded to several times its design strength. And how the materials react to this huge load is going to determine what happens to the ship. That's nice and tough.
As it turns out, Titanic's steel is surprisingly strong.
The steel shows toughness almost as good as modern steels and was actually quite adequate for the application of the Titanic. Okay, this is nice.
Fakey's work has helped to settle a debate that's raged for nearly a decade.
This is nice, tough material.
Investigators can now say with certainty that Titanic's steel was not flawed, and it did not contribute to the breakup of the ship. Next, investigators shift their focus to another potential cause: the powerful flooding of Titanic. In the first hours after the collision, Titanic took on hundreds of tons of water per minute. Did this added weight begin to tear the ship to pieces? Magellan helps investigators look for signs of damage in the hull caused by flooding.
Trying to do this without making a mess.
Along a region known as the well deck, the team spots a series of cracks.
We're looking at a significant crack in way of the aft end of the well deck region on the starboard side.
They believe the cracks were formed as the bow sinks deeper into the water. As the stern rises, the stress increases throughout the vessel. Today, investigators find clear signs of that enormous tension on the wreck. This opening is known as an expansion joint. It was designed to relieve tension in the upper decks. The separation should only be inches wide. Now, it's several feet across. The night of the disaster, the joint is pulled open, causing the forward funnel to topple into the water. Next, the team surveys the break area itself, and the devastation is dramatic. How did flooding lead to such destruction?
The breaking up of the Titanic looks like it was a slow process. Not like bringing down a building where you plant all this dynamite and boom, and it all collapses down the middle. A ship breaking up is not a pretty sight. It's a very slow, agonizing death to a very large piece of machinery.
Buckle down. It would be great to get images from this side and from the other side.
To model the final moments of the breakup, investigators will build a virtual Titanic, where they can simulate the flooding to see what happens.
This is a very clean, very straight fracture line too.
At the naval architectural firm Gibbs & Cox, investigators build a computer model of the Titanic to reconstruct the breakup. Bob Silsky is one of the structural engineers. He wants to see how flooding affects a specific part of the break area known as the ship's aft expansion joint.
We started with a basic analysis of the ship, knowing, of course, that the weakest area would be at the expansion joints in the deck, and that's where we zeroed in on our stress analysis.
Silsky's model also accounts for the strength of Titanic's steel, which we now know from the steel test. To begin the process, the bow is slowly flooded. With forward compartments full of water, the model changes from purple to blue, indicating that the stresses are increasing on the ship's hull. With 6 compartments filled, the model is transformed again. Red regions indicate the areas of highest stress. More than 65,000 pounds per square inch are exerted on the expansion joint. This is more than Titanic's steel can handle. And the great liner begins to break near the expansion joint and third funnel. Silski's results have some startling implications. First, on the night of the disaster, many Titanic survivors testified that the stern rose nearly perpendicular during the sinking. But according to the new model, that would have been impossible. The stern never rose more than 12 degrees before the ship broke.
We know from our analysis that the ship didn't trim by about more than 12 degrees, and at that point the stresses became very high in the midships area. That's when it would have broken.
The model also suggests a clear sequence of the ship's destruction. Titanic broke from the upper decks first. Her bottom failed last. This scenario suggests a provocative new idea. After Titanic's midsection crumbles, could the bow and stern still be connected? Did a large section of hull bottom hold the ship together for a brief period underwater? To investigate this theory, researchers need to find this missing link that connected Titanic's bow and stern. Back at the site, the search is on for the phantom piece of hull.
Start to sink here.
Former French Navy commander P.H. Najolet believes he saw the large hull section more than a decade ago. He thinks it might be in an area of debris some distance from the stern.
I think that it's my position.
Najolet, however, is not exactly certain of its coordinates. Previous attempts to find it have failed.
On this map, here is the bow section, here is the stern section. I don't remember if it was in 94 or 96. We tried to see again this piece, and we don't find it.
There are intakes on this piece here.
I think maybe I was dreaming, you know. Maybe it's a dream. 37.
If investigators can find the missing piece that held the bow and stern together, it will be one of the most intriguing discoveries of the expedition.
The bulkhead right in here.
The piece could help them reconstruct when and how the bow and stern actually separated.
After is the hand of the...
To find the piece, Magellan sweeps the outermost portion of the stern wreckage, working inward to the stern itself.
That's your ship sticking out.
The team begins its search late at night, embarking on a lonely trek across the debris field.
Yeah, we're going to move straight ahead. There's some stuff up here.
Sounds cool. I understand you're moving out of 320?
Yeah.
Roger that, thank you.
Some small stuff right here. About 290.
Just before dawn, the team is down to a skeleton crew. The bridge is quiet. The Magellan pilots guide the ROV closer and closer to the stern wreckage. Suddenly, out of the darkness, the team spots something massive. Could it be the missing hull bottom that they were looking for?
Okay, bridge. We assume that we're sitting on the piece here. You gotta wake the scientists up.
That's the line.
The scientists are roused out of bed to verify the discovery.
Do you see the CVK on your right of the screen?
Just about 4:30, I had a knock on the door with a very pleased announcement that we found it. We came right down on it. What it was a huge section of the bottom of the ship. I am sure that those who look for the beauty of chandeliers would yawn over it, but to an engineer, it was magnificent.
For the team, the Phantom piece is quite an impressive find.
At that point, because that's where
they calculate it's a staggering 92.5 feet across.
This is a pretty big piece here.
It spanned the entire width of Titanic.
Looking 290. Try a few different things on this sonar here.
It also exceeds 26 feet in length. Its tattered condition provides testimony to its incredible story. The fact that the edges are bent and not cracked indicates that it was slowly pulled apart. Unlike the decks above, it did not give way rapidly. In the center of the piece is a massive beam called the keel. Given its tortuous appearance, it was probably the very last part of the ship to break. With this evidence, it now seems likely that when Titanic disappeared beneath the ocean waves, she was still in one piece. But somewhere in the first 500 feet, the hull bottom finally gave way. Here, the bow and stern began their separate and very different journeys. Ironically, Titanic's keel, the last section to give way during the breakup, was the first piece laid down during the ship's construction.
When these ships were built, they were built from the bottom up. The first thing you laid was the double bottom. This is the backbone of the ship. It was the last line of defense in the end. It was the last thing holding that ship together.
A storm front moves in, threatening the operation. Paul Mathias and the crew of Nautil are retrieved from dangerous seas. The harsh conditions of the deep begin to take a toll on his photographic equipment. Salt water also corrodes connectors, seals, and wires.
Because it sets right on top. Well, we've been faced with challenges. That is the way this one is. It just has one. Taking this equipment to a couple hundred feet pales by comparison to taking it to 13,000 feet. And there, the environment is vicious. It's very tough on connectors, connections, wiring of any kind, and it's salt water, so it's very corrosive. Okay, so why don't we try to connect?
The crew on Ocean Voyager is also running into some problems of its own.
It looks like the compass is turning a little bit.
You should be 180 relative.
Rough seas are making it difficult for the captain to hold the ship steady above the wreck site.
It's tracking, whereas it wasn't before.
Good.
As she drifts, she drags Magellan, endangering the ROV.
Come on! Left turn, Kurt!
Left turn. Left turn.
Magellan has to be retrieved.
Okay, hold back.
At the surface, the 2.5-ton vehicle is tossed around like a toy.
I'm trying to turn.
Now, you got slack. Go.
The crew wrangles Magellan's cable as it's pulled from the ocean.
Roger that. You gotta move that arm, Kurt.
I am. I'm trying to lift it up.
All right, easy on tucking him up, Troy. Roger. Kill your depressor light.
Forceful winds kick at the crane, making it difficult to dock the robot.
Watch your head. Come back for right. All stop.
Crews quickly scramble to anchor Magellan safely to the ship.
Stan, don't get in between there and the deck. Easy boom down. Coming down slow.
Now all they can do is wait out the weather.
How am I looking on the handrails there?
Hurricane Bonnie is now moving quickly up the coast, threatening the expedition.
If it's moving at 15 miles an hour to the north.
The team takes the storm seriously, and they have to decide whether to risk staying or to run for cover.
That means it's moving almost 4 times faster than we are. The remnants of this could be debilitating on the ship itself.
Leaving means giving up the expedition.
I just want to object that I think if we break off site right now, we are effectively giving up the second leg. That's my opinion. I don't think that we're going to.
Much like that.
Yeah, I don't think we're going to get back here and get any really effective plan done.
The decision is made to wait and see if the storm changes course. Accurately predicting weather at sea is a matter of life and death. Mistakes can be fatal, just as they were with Titanic. The night of the disaster, the ocean was as flat and placid as a lake. But the calm seas were misleading. Lurking in the darkness, dangerous icebergs drifted further south, occupying waters where they were seldom seen. A small miscalculation led to colossal catastrophe. Today, other forces are destroying Titanic. The great ship is slowly disappearing. Some scientists believe her steel is actually being eaten away by deep-sea bacteria. As the bacteria consume the ship, they create the rust-like structures dubbed rusticles that blanket nearly every surface of Titanic. Rusticles also decimate her interiors. Once glamorous, they're being transformed into grotesque and haunting chambers. Little by little, the rusticles are devouring Titanic. And nobody can say for sure how long until the great ship is gone forever. Dr. Roy Cullimore is trying to gauge how quickly the rusticles are destroying Titanic.
Idolizing the machines that can break the genetic.
To do this, Cullimore needs to understand the rusticles' diet.
Okay, and why are you different? Well, because these...
He wants to know what types of steel the rusticles prefer to eat.
We've got a really tough steel. We've got a very strong steel. We have a mild steel. We have steels that have been twisted and bent and tempered and burnt and hammered. And what we want to do is see whether the way that we've treated the steel affects the way the rusticles first grab onto the steel.
With a break in the weather, Cullimore dives to the wreck to deploy his experiments on Titanic's stern.
I believe we're looking at the collapsed bridge wing.
When he surfaces, Cullimore also uses Magellan to place experiments on Titanic's bow.
Okay, let's see what I can do here.
Through his work, Cullimore has already calculated that nearly 20% of the bow section has been devoured by the rusticles. Today, he's refining those estimates, and the rate of decay is alarming.
When you look at the Titanic today, I would say that the rusticles are removing 0.1 of a ton of iron from the steel every day. And so it's only going to be the matter of possibly 90 years before the Titanic biologically implodes, collapses into itself, and eventually simply becomes an iron ore deposit on the floor of the ocean. And there's an equal number in the
For biologist Roy Cullimore, expeditions like this are critical.
When there's no movement, like in Nortil, when
the rusticles are destroying evidence of Titanic's disaster, just as we're beginning to understand her story. For Titanic, time is running out. Through the work of Paul Mathias, the world is getting its most complete view yet of the Titanic wreck site. A mosaic of Titanic that will live on for generations to come. For the first time, we can see a complete overview of Titanic's bow and stern. Titanic's bow can be studied as if the blackness of the North Atlantic had been removed. The destruction of Titanic's stern is catastrophic. It's almost unrecognizable.
The mosaics provide the overview and the relativity within the wreckage. The stern itself hidden by a flapped over piece of deck. If you look at them as an overall picture, they can be very beautiful.
Now this is actually part of the guts of the crane.
If you went down there in a submersible and you looked out the window, you would never see that.
The extent of the damage, I think, is visible.
It's totally artificial, but if you took the water away, that's what you would see.
You see here, that don't see elsewhere on the ship, is the side shell.
For the investigation, the photo mosaics are a breakthrough.
Life rails anywhere on the stern.
That's right.
A great asset as the team combs through the wreckage to reconstruct the disaster. So far, the investigators have made some remarkable discoveries. They now believe that when Titanic grazed the iceberg, some of her rivets gave way, creating a thin opening in the ship's side. As she sinks, the bow section starts to crack. Titanic's stern rises. The structure suffers tremendous strain. Despite the apparent strength of her steel, Titanic's midsection crumbles. Titanic, however, does not break apart until the vessel is completely submerged. For a short period, she's held together by her keel and hull bottom. Still, investigators want to know the rest of the bow story. How fast did the bow fall as it plunged 2.5 miles into the abyss?
There is, of course, a lot of argument within professional circles about how fast a ship or parts of a ship are going to go down. Some would say that it would go down slowly, others say it will go down fast, it will drop like a rock. These are things that we don't know yet.
Starting at the top, we have the famous rails, of course, around...
To Williams and the team, the photo mosaic provides some very clear indications of the bow's speed.
The hatch here.
The structure is remarkably intact, which suggests its trip to the bottom may have been very slow.
This can give us some guidance as to the speed of descent. If we look at the mosaic, what we see is a fairly clean structure. It's lost its funnels, the mast has been driven down.
And also the mast.
But there are some small pieces on the deck which, if it had been traveling very fast, we would have expected to have been blown away by the force of the water. Slow down as quickly as the structure as it hit the seabed.
If the bow sank quickly, the team believes that her railings would have been torn away. But most of the railings remain intact. The bow cranes are also still in place. Another sign of a slow descent.
And the whole thing, when you look at the detail, is of smoothness, slowness.
The photo mosaic provides some clues about her speed.
Now this is like a torn pipe.
Now investigators would like to know how the bow actually plunged to the bottom.
We need to understand how it actually traveled to the seabed. Did it rotate? Did it tumble? Did it just glide, or did it even stall and go into a falling leaf type pattern?
Back at the wreck site, investigators are building a case for the bow's fate.
Yeah. This looks like it's overhanging a bit.
On the port side, they examine a series of unexplained 90-degree bends in the hull plating. It appears that when the bow suddenly hit the sea floor, the impact created the bends.
Let's move off to the right along the mud line if you could. Okay.
On the opposite side of the ship, there's a large hole near the mud line. It too appears to have been formed by a sudden stop.
Global damage of the ship coming in on an angle and striking the seafloor.
Bow first on the starboard side would tend to buckle it back.
That's still continuing. You can still see the upper reach.
Yeah.
Okay.
Given this, 2 hurricanes now have the potential to bear down on the expedition.
Once we finish the trim test,
The team has a 48-hour window of opportunity to continue its investigation.
Okay, so that means we're operating for the next 8.
Then, trained seamen and novices alike will brace for the worst.
With our system. You understand, it's going to be a very quick training period.
The prospect of rough seas is unnerving.
You want to get in the water tonight, from what we understand.
Okay, it looks like it's going slow.
Get it, keep getting it.
Now the expedition takes on a new sense of urgency.
It's coming around.
Come on.
Magellan heads to Titanic's stern one last time.
Keep your head. Spin right. 20.
Spin right 20.
Investigators would like to figure out why Titanic's stern is such an exploded mess.
All right, Kurt, give me a couple little bit to the left.
Okay.
Titanic's obliterated stern has puzzled scientists for years. Compared to the bow, the stern is radically damaged, nearly unrecognizable as a ship. Investigators would like to know how this destruction could have occurred.
What it does show is a stark contrast with the bow itself that we saw earlier. When you look at the two mosaics, the bow and the stern, you see the bow, reasonably good condition. If you look at the bow, it's quite pristine. Okay, it's fairly clean, it's been wiped clean in a few areas, but the stern is a wreck. It looks as if a bomb's hit it. And in fact, that's probably the equivalent of what happened.
After Titanic disappeared, some survivors claimed to hear thunderous, explosive sounds deep below the surface.
Not until she was entirely submerged. The explosion sounded like reports of a big gun in the distance. Third Officer Herbert Pittman.
From the lifeboats, first-class passenger Edith Russell also heard similar sounds emanating from the deep.
There was a heavy, heavy explosion beneath the water, then a second and a third. These explosions actually thrust our lifeboat farther away, as by an invisible hand. First-class passenger Edith Russell.
Investigators want to find out if these explosions are somehow related to the destruction of the stern. Magellan's cameras scour the stern wreckage, looking for answers.
Okay, I think it's going to start getting cloudy here soon. You want me to come up on that hanging piece real slow?
Roger that.
See, I got the current coming right, you know, from my rear. Am I clear on the left?
One area of intrigue: Titanic's aft poop deck. The deck is peeled back, almost like the lid of a sardine can, revealing understructure and ribbing. Scientists think the source of the explosions might be found beneath these decks. Directly below the poop deck are a series of holes that were not flooded. Instead, they were filled with trapped air. As the stern sinks, water pressure compresses the trapped air until it violently implodes inward. Then it violently explodes outward, blasting back the poop deck. Some historians believe one area that imploded, then exploded, was Titanic's refrigeration holds.
Well, that's where the refrigerated cargo was in the stern.
The holds held enough food for more than 2,000 passengers on a 7-day voyage.
When you have
when you have 2,300 people and they're going to be on board for better than a week, the quantities are really enormous.
A fresh meat, 75,000 pounds. Poultry and game, 25,000 pounds.
The space required to hold Titanic's food was massive.
2,500 pounds of sausage, that's 10,000 pounds.
The equivalent of nearly 4,000 average-sized refrigerators.
1,000 sets, fresh eggs.
A large and potentially explosive space.
1,200 quarts of fresh cream.
Historian Klaus Wetterholm suspects the refrigeration holds blew up.
This is where we find so much damage.
He points to some provocative evidence. The holds, like much of the ship, were insulated with cork.
Whoever has been on a ship knows that that's what you do on a ship, you eat.
According to Wetterholm, when the stern was exploding, it released an incredible amount of cork.
Perhaps. On the night when the ship went down, many survivors said that there was a lot of cork on the sea. Some of them refer to this as a carpet covering the whole sea, red-brown carpet, cork, billions of fragments of cork. And this come from the ship.
Based on the wreckage of the stern, investigators develop a destruction sequence to try to determine what happened. They think that as the stern reached a depth of about 200 feet, the water pressure compressed the structure. All trapped air was then blasted out, with enough force to level nearly a square mile of houses.
If any structure sinks that's still intact all around, as it goes down, it becomes compressed from the water pressure. And then when it collapses, the air is compressed, and then it expands outwards again, like an explosion.
In their computer model, the first compartment decimated is the turbine engine room, followed by the electrical machinery room, then the stern tunnels and the peak tank. Then, the spaces above would collapse in an unidentifiable sequence.
They're highly compartmentalized, rigid bulkheads covered in cork, airtight spaces.
Back at Carderock, the team tracks the route the air took as it wreaked havoc on the stern.
50 or 80 feet. There were various routes for this expelling air to come up through. It's following a maze. The air follows a maze through the structure, and at each turn, at each bend, it disrupts it, it destroys it.
One of the most direct and destructive paths the air took was up the third-class staircase, directly below the poop deck.
Most probably the stairwell access is the route that the air took, and it came up that stairwell into the lounge area where it congregated underneath the deckhead, and then through buoyancy, probably more than anything, just lifted that deckhead over and laid it down.
Escaping air, it appears, had the power to ravage the stern, contorting and twisting her into an exploded mess.
From then on, it was a wreck. It was disrupted and broken. There's no evidence that it rolled over because we'd have lost a lot of the loose structure on top. It was vertical all the way to the seabed, all the way to the seabed.
The state of the stern wreckage once defied description. Dangerous and foreboding, it was largely unexplored. Its story completely unknown. A groundbreaking exploration has changed all that. Now we can see and understand the stern through the eyes of science. Nearly 100 years ago, the great RMS Titanic embarked on her maiden voyage. A ship of dreams. She had a bright future beyond the horizon. A destination she would never reach.
I think that the enduring public fascination kind of spurs us on to find out exactly what happened. It's such this huge mystique.
It's taken nearly a century for scientists to piece together Titanic's demise. And they've realized the tragedy is far more complex than ever imagined.
And most people would say, oh, it sank because it collided with the iceberg. It didn't really sink because of that. That was the initiating event. Most vessels sink because there is a series of consequences which lead you to the final loss.
Now that we can see Titanic's final moments with greater clarity, we are more awed by the scope and scale of her destruction.
Well, one thing we did learn from the final hours of the Titanic, that it was certainly a lot more chaotic than we had ever thought before.
Locked in her tortured steel is the dramatic account of what happened. New expedition discoveries have filled in missing parts to Titanic's story. Innovative techniques have now revealed the ship in a startling new light. Groundbreaking experiments have finally solved long-standing mysteries.
What this whole expedition has been able to do is put pieces together to give you, or give the world really, a full story of what happened that night. How did the ship break out? Where did it end up? And why did it end up there?
As the expedition draws to a close, a hurricane pushes the team offside. Success and celebration are tempered by the power of the sea. Deep below the turbulent waves, Titanic rests. Silent for so many years, her wreckage has had much to say. We have finally pieced together many of her long-held secrets, traveled deep in search of answers. And now, we know Titanic as never before.
is that the bow came down following a corkscrew pattern, a helix. Came into the bottom in a stable glide path. Landed down into the mud. Bow stopped suddenly. The rest of it wants to come around behind it, and it'll try to fold it up like an accordion on one side and split it on the other.
To test this new idea, the scientists conduct an unusual experiment. One that charts new waters in marine forensics. At the Carderock facility, a team of scientists will sink a model of Titanic's bow. Surprisingly, those who build ships know little about them once they leave the surface.
Out of the picture, guys. It's all yours.
The way the vessel falls through the water column is a complete unknown. The navies of the world have carried out experiments, but on military-type ships, very specialist. What we haven't got is for general commercial shipping a knowledge of what happens in the water column. Titanic will fill a piece in that picture and give us one brick in the wall of that understanding.
The model is ferried out to its drop point beneath a tow cage. The cage is suspended from a massive indoor bridge. Its steel girders span more than 12 million gallons of water. This is one of the largest test tanks in the world. As part of the development team, test manager Tom Waters makes some final adjustments. The bow model is just under 5 feet in length. The bow's mass, weight distribution, and major features are represented.
The real interest here is what happened when the bow separated from the stern on Titanic. So the model testing of the bow should show us, hopefully, any particular attitudes that the bow may adopt. There are many, many issues that need to be looked at.
At the edge of the tank, scuba divers get into position. The bow's descent will be tracked through sonar. The model will send out an acoustic signal, which will be picked up by underwater microphones. The microphones will relay the acoustic signal to a computer for analysis.
Diver, stand by. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
The bow did not corkscrew as they expected.
That was interesting.
A revelation to the team.
Did it roll, Chip? Did it look like it was wanting to turn at all? Huh.
That was interesting, guys. She took a nose down, tended to glide a little bit, and then she seemed to stall and settle in stern and kind of settle up even keel stern. About the same thing, it kind of went down and then kind of...
No, I saw out,
right,
back, out,
What
back.
surprised us all, I think, is the stability in the situation. We had expected that possibly it would swing one way and then the other, or we might see some tumbling and a sort of chaotic issue. But in fact, what we saw was something very, very stable.
Over the next 6 hours, the model is repeatedly dropped. as investigators zero in on a statistical average. These lines illustrate the bow's flight path is stable.
Divers in position. 3, 2, 1.
In each test, the bow does not corkscrew.
There it goes again. Same thing. Consistent.
A metal flange is added, mimicking Titanic's actual wreckage, to see if it causes a corkscrew motion. But the bow's fall remains consistent.
It was not spiraling. It was not a straight glide path. It was a bunting process where the vessel swooped down and then stalled, and then swooped again and stalled, and continued to do this right down to the seabed.
So, I don't think she took a tight corkscrew like we thought.
Not a real.
The tank test results also indicate that the bow was falling at approximately 22 knots.
Right.
Much faster than Williams expected. When the bow hit the seafloor, it looks as if it struck nose first,
Knifing into the mud, and quite deeply into the mud at this point.
plowing up mud, signified by the color red on this seafloor map.
Squeezes this seabed, slumps back.
The map also shows a mound of mud on the ship's port side, which indicates a slight rotation upon impact.
Into the seabed and pumped up this side.
With this evidence, the final moments of Titanic's bow becomes painfully clear. After receiving a fatal blow from the iceberg, the bow begins a long, slow journey to destruction. The watertight compartment's overwhelmed, thousands of tons of seawater pulling her beneath the surface. Deep below, she begins a seesawing pattern as she slowly falls. Six minutes later, she smashes into the sea floor, plowing up the mud. The sudden stop causes her port side to bend. Water explodes from the ship, creating the hole in her starboard side. For nearly 100 years, the bow has kept this part of her story hidden in the darkness of the deep. Now, the light of scientific discovery has revealed new understanding of Titanic's disaster. Ominous clouds move in on the Titanic site. The weather threatens again. Zodiac transfers are more difficult, even dangerous. For some members of the team, this is their first expedition at sea. The sight of big water can be troubling. Two hurricanes now have the potential to bear down on the expedition.
Once we finish the trim test,
The team has a 48-hour window